We've learned previously, when we were going through our discussions of Castle, that voltage is an electric pressure, and we can indicate the electric pressure in wires using a color coding system. Wires that are connected to the positive terminal of the battery are considered to have high pressure and are colored red. Wires that are connected to the negative battery terminal are considered to have low electric pressure and are colored blue. Whenever you have a pressure difference across a resistor, you will get a current flowing through that resistor. And in the circuit on the left, the current that's running through the resistor, the round bulb, is the same as the current that's going through the battery. That bulb will have a certain brightness, which I'll indicate by the starbursts. In the middle circuit, everything is the same, except we've switched out a long bulb for the round bulb. Well, long bulbs have more resistance, so for the same pressure difference, we're going to get less current going through this long bulb than the round bulb on the left. Therefore, this long bulb will not be as bright as the round bulb on the left. Things are similar in the circuit on the far right. The top wire is high pressure red, the bottom wire is low pressure blue. The pressure difference across these two bulbs of equal resistance must be equal, so a red to yellow pressure difference is the same as a yellow to blue pressure difference. Those pressure differences are smaller than those of the previous two bulbs, so these will be the dimmest. What we see here is that all of these circuits have the same number of batteries, that is, they all have the same pressure difference. The one on the left has the least resistance, the one on the right has the most resistance, and the one on the left has the most current, the one on the right has the least current. These three variables can be related into an equality in Ohm's law. The equation for Ohm's law is I is equal to delta V over R, where R is the resistance in ohms, symbolized by the capital letter Greek omega. Often, Ohm's law is written without a fraction, as delta V is equal to I times R. If we were to set up a circuit and try different values of voltages by using, say, different numbers of batteries, and measuring the current in each case, and then plotting those values, sometimes we would get a straight line, as is shown on the left. Other times we might get a curved line, as we see on the right. On the left, that is indicating an ohmic resistor, where the value of the resistance, indicated by the slope, is constant, no matter what number of batteries you use in the circuit. A non-ohmic resistor has a resistance that will vary depending on how many batteries you use in the circuit. For ohmic resistors, the resistance is constant over a large range of pressure differences, and for a non-ohmic resistor, the resistance varies depending on the pressure difference. Carbon resistors tend to be ohmic in nature. Light bulbs with filaments tend to be non-ohmic. Let's try an example. A hairdryer with a resistance of 280 ohms is plugged into a standard outlet. What current flows through the hairdryer? It wouldn't be a bad idea for you to memorize that in the United States, a standard outlet has a pressure difference of 120 volts between its two terminals. So if we use Ohm's law, with delta V being 120 volts and the resistance being 280 ohms, we find that the current is 0.43 amps. You can think of it as 0.43 arrow tails flowing through that hairdryer. And we would want to design the hairdryer so that it could handle 0.43 amps of current. Suppose the hairdryer is plugged into an outlet with a potential difference of 220 volts. Find the current. Assuming we could do this, the only number that would change would be the numerator, and that would give us a current of 0.79 amps. Chances are your hairdryer is not designed to handle 0.79 amps, and you would get a zzz pop effect, and your hairdryer wouldn't work. This is why in countries that have different standard voltage differences, they make plugs that are different shapes and sizes, which Richard Dawkins has called the Great Plug Conspiracy. Ohm's law gives the relationship between the potential difference, i.e. the voltage across a resistor, the resistance of the resistor, and the current through it. And there are the equation for Ohm's law. Resistance is measured in ohms. Ohmic resistors maintain the same resistance over a wide range of potential differences, while the resistance of a non-ohmic resistor depends greatly on the applied pressure difference.